Okay, this first problem is kind of easy just because I noticed that it has a -9 over here. And so what happens when you have something that's -9 and then the absolute value, because this is always positive, you can't set this equal to a negative number. So we're going to write no solution. So that should save me some time on my video. Now, for this one, I'm going to try to start isolating. So I'm going to do -5 and -5, and now I'll have a -10 on this side. And then I have this 2 outside of the absolute value sign. And in order to get rid of it, I'm going to divide by -2. I'm also going to divide this by -2. So that's going to get rid of it, and I'm going to have 3x minus 4. And then over here, I am going to have a +5. But now I need to set up both of these problems because it could be a +5 or a -5. So now I'm going to do 3x minus 4 equals +5. And then over here, I'm going to do 3x minus 4 equals -5. And so I'm going to solve this one out. So this is +4. So that gives me 9, and now I have 3x. I'm going to divide by 3, and this gives me x equals 3 on this side. Or over here, you have the +4, and that's going to leave you with a -1 and a 3x. And then when you go to divide by this, it's going to give you a fraction. So x equals -1/3. So if I draw my number line, I'm going to have 0 here, and then really close to 0 in between 1, I'm going to have -1/3, and I'm going to put a dot here because it could be there. Or it could be up here, x could be at +3 as well. So you have those as your answer. Then problem 61 looks like this, and these ones are harder for me. My brain doesn't quite work like this, but basically what I like to think about is x minus 1 being in the middle, and then it's going to be less than the +4, and it's going to be greater than the -4. That helps my brain. And then I still have to get rid of this and do this so that I get the x alone. So now if you do the -4 and the +1, you end up with -3, and then you have your x in here, and then you have the +5. 4 plus 1 is 5. And so now on your number line, you have +5 being up here, and you have -3 being down here, and you have the x is going to fall between those. So just with brackets, because there's nothing that says equal, so there's the 0, and it's going to be anywhere in here it could fall. So from -3 to +5, that would be the solution. All right, gets harder and harder. All right, for this one, I'm going to think of it as the -9 and the +9. So 2a plus 5, and you're going to keep it like this, 9. And then over here, you're going to have to flip the sign. And that's one thing I found out the hard way. I did not do it like that several times, and it didn't work out. So now you have 2a plus 5, and so I'm going to go like this and take away the 5 on both sides. So now I have 2a is greater than this. Take away 5 is going to be a +4. Divide by 2. Divide by 2. So a is greater than 4. Or on this side you have the 2a. So I'm going to do +5 again. Or sorry, -5. Take away 5. Take away 5. So now you have a -14. And then 2a. And you're going to divide by 2. And you're going to divide by 2. And then you're going to have a. And it's going to be a -7. So if this is my number line, you are going to have your 0. And you're going to say that here's 1, 2, here's my positive 2, and then here's my negative 7. And A is going to be less than negative 7. So the negative 7, wait, A is going to be less than 7. A is going to be greater than positive 4. Whoa, positive 2. A is greater than positive 2. So, oh, I forgot this. So I need my bracket. And it's going to be greater than positive 2 going this way. And then it's going to be a bracket. And A is going to be less than negative 7. So it's going to go that way. So it's going to be, really it's going to be negative infinity to negative 7. And then it's going to be a union with this one, which is going to start at positive 2 and go on forever to infinity. And what I did forget is I need my bracket here because it's going to include 2, and I need my bracket here because it's going to include negative 7. So hopefully that all makes sense.